Okay, hi everyone. Good morning, good afternoon, or good night, depending on where you are in the world. Thanks again for joining us today. Welcome to today's CNCF webinar, Staying on Top of Ongoing Kubernetes Security Hygiene. I'm Christy Tan, Marketing Communications Manager here at CNCF. I'll be moderating today's webinar. We would like to welcome our presenters today, Zohar Kaufman, co-founder and VP of R&D at portshift, and Ariel Schuper, VP of Product at portshift. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinars page at cncf.io/webinars. With that, I'll hand it over to Ariel and Zohar to kick off today's presentation. Take it away.
Thank you very much. Thank you, Chrissy, and hi everyone. Welcome to our webinar. Hi, Zohar.
Hello, Ariel.
Nice to meet you. Let's go to the agenda. Let's see what we prepared, what we cooked for the people. So, as I said again, hello everyone for joining. We're excited to have you with us. We want to talk about few things that will keep your Kubernetes cluster secure, will keep your Kubernetes hygiene at a high level, and using native open source tools or just tool that everyone can use. And the first topic we want to talk to you about is vulnerability scanning. So I'm sure it sounds to most of the people as a cliche, but we want to talk about a new approach, a runtime scan, not a classical scan at CI/CD or the registries, but a runtime. So you might ask yourself, runtime scan? Sounds strange? Wait and see. The next topic we want to talk about is runtime risks. How can you discover runtime risk before they happen? How do you do it in the CD pipelines? So everybody is used to doing the CI to check for things, but what can be discovered in the CD, which can provide an early detection and avoid those risks from happening in reality. The next stage is pod deployments. We call it the good, the complex, and the intuitive way, and is how to harden deployments of pods without sacrificing security and without going into too many complex configuration. That's another challenge. We want to show you how you do it. Network policies is next on our agenda. Network policies are always required. We want to talk to you about what happens when the network policies you're trying to construct are associated with elements which are outside the cluster, associated with elements which is not containerized, and how you can create it efficiently and secure. Last but not least, the very super interesting topic, which I think sometimes is a little bit overlooked, and this is the Kubernetes cluster itself. How do you protect the Kubernetes cluster? Not the worker nodes, not the application, but the Kubernetes elements, like the master node or any associated service, whether it's the API or the DNS or the kube controller. How you get security or comprehensive security for every single piece in your deployments. So that's about it. We're going to wrap it up, so do some shareables, questions, and we look forward to have an exciting event today. Zohar, go ahead.
Thank you, Ariel, for the introduction. So we'll start out with vulnerability scanning, our new approach for that. So first we'll discuss how classical image scanning worked. We'll focus, on vulnerability and security of images for scanning because it's traditional. Everybody is doing that. I know that in the past, security was always viewed as an impedance to the speed of production, but hopefully these days are behind us. If you have a security breach, as you probably know, this is one of the most costly things that an organization can endure. It takes years to build a reputation and only seconds to tear it down completely. So the classical image scanning approach is to scan during the CI while you're building your images, and then continuously scan the registry for updates for updated CVEs. This way we find the risk in advance before the images are deployed in production, hopefully. It's a classical shift left approach. It enables the developers to fix the issues they find quickly and efficiently, and also reduce the friction between the DevSecOps and the developers. So what are the challenges of this classical approach? So first, it requires integration. Without preliminary integration, either in the CI/CD pipeline or the image registries, users are actually blind to the vulnerabilities and the risk. For assessing which pods in their deployments were built from vulnerable images, users usually need a security agent on each node of their Kubernetes cluster in order even to show them what's happening. Some of the pods may arrive from external repositories, and then they are not scanned. Pods may also use multiple sidecars, and these add-ons elements are not scanned and may contain also vulnerabilities. Scanning image registries might be inefficient due to the number of images that are produced and stored there. Usually, it's not proportional to the number that actually is deployed in runtime. New vulnerabilities can be found after the deployment to production. So somehow we need to continuously do that. Scanning registries typically happens once a day, and sometimes the time to response here is too slow. And we are not scanning basic components, like, for example, Kubernetes components themselves. So just to strengthen the last sentence, these are two CVEs, so that were just released and discovered on June 1st. One of them, these two are actually in the Kubernetes core system. So actually, constantly monitoring Kubernetes clusters is critical. So one might say, I'll just upgrade to the latest, but one of them was fixed only in 1.15, Kubernetes 1.15 and above. The other was fixed only in 1.16 and above. So if you are left out in some old Kubernetes version, you will not even have the upgrade path unless you upgrade your whole Kubernetes, and you will not know that you are vulnerable. So we introduced Kubei. Kubei is an open source runtime scanner. It was born not because there is a lack of open source scanning tools. There are quite a few of them. It was born in order to address the DevSecOps needs. Security teams are eager to understand the current risks of their Kubernetes clusters now, in real time, without any preliminary integration. The DevOps teams are eager to get efficient scan without scanning scalability bottlenecks and failure in production. So Kubei is, like I said, an open source. It will fetch and scan only the images used by running containers. So only the ones that are actually now running in your production, which for large enterprises, like we said, is a fraction of the images that they have in the registries. So these images now in production, it doesn't matter whether they came from CI/CD or not. They can even be the Kubernetes system elements. Kubei will scan them all, and you'll get an accurate real-time status of all the images in the cluster and their health. So how Kubei works? So Kubei doesn't require any integration. It's a temporary deployment in the Kubernetes clusters. Kubei distributes the loads between a configurable number of scanner jobs. And at the end of the scan, it will generate a graphical report of its finding. So now it's time for a demo. So wish me luck. So you see here, first of all, let's install Kubei. So installing Kubei is very simple. You just apply one YAML file from GitHub. So we'll soon see the page of there in a moment. So you see, I already actually did that. So not much was changed. And once we did that, all that is needed, we can get the specific pod of Kubei. You see it here now. And now you can we can just do a port forwarding. So we'll port forward the port 8080 of this pod to our local machine. This is needed because we'll now see the scanning results, and you'll want to keep the privacy of the scanning results. And we can also see the logs of the scanning. So we'll do that all in a moment. But first, let's look at the YAML file. So this is the YAML file. You can see there are a few configurations that you may change. This is the level of parallelism. So how many jobs are running in parallel. So currently it's configured to 10. We can scan a specific namespace if you like, or a list of namespaces, or alternatively all of them. We can ignore vulnerabilities with a certain level. So here we ignore vulnerabilities with medium severity, we show them, but low severity we will not show them. We can ignore also namespaces. So here we ignore the Istio system namespace and the Kube system, but as I said, it's more than recommended to also scan them. You can also have few advanced options that we will not pass here. So actually, let's see how it looks. So this is the UI, and we need just to press here go. And while doing so, we will also see the logs. So in the logs, you can see that the scanning is progressing nicely. And you can see here intermediate results. So currently, you can see the number of vulnerabilities. As you can see, Kubei is very fast. It's scanned by now hundreds of pods, and we see here the results. So let's make this screen bigger. So for each of the images, so we see here the first image, and this is all the lines belong to the first image. We can see all the CVEs, and if I click a specific CVE, then I'll just jump and see the description of this CVE. And also we can see for each image what the vulnerabilities, so which package should be patched. So here we see lots of Linux and systemd and glibc. So you can see and exactly know what to do here. Searching for Kubei is very simple. You just write Kubei and GitHub. And surprisingly, this is the first answer in Google. So you can see here the page of Kubei. There is nice documentation here. You can see also the usage. This is actually what I just did. And you can also read about the different configuration available. So this is it for Kubei. And we'll go now for the next topic. So I'll stop sharing and give Ariel the mic.
Thank you, Zohar. Thank you very much. And while I'm sharing my screen, I think you touched the points which I think are critical. Why we call it runtime scans. The fact that I hope you all see my screen. The fact you can immediately get a snapshot, accurate snapshot of all your vulnerabilities, those which are coming from your application, those which are coming from your deployments, those which relate to the system. And as you touch it, these are really very quick and easy because you can run multiple scans in parallel and get a very quick understanding of what's your risks. And thank you, Zohar, for sharing that. I'll take it from here. And I want to move one step forward, in the journey of maintaining our cluster secure. And I think the next stage after we pass the CI is let's go to the CD, right? And in the CD, when people are preparing for deployment, creating the Helm charts or the kubeconfig files or anything which prepare the deployment, we think that it's be critical to do advanced detection of potential risks. Now you can ask myself, you can ask yourself, you can ask me what can go wrong. We didn't even deploy anything. And the answer is yes, if we can assess the risk potential prior to the deployment, we can avoid the risk before it happens, before it becomes real. Now, what do I mean? So there are a few elements which we believe that if you make the right detection before the right review, can save you some time. And since we are having a proliferation of CD tools, proliferation of options, we want to do it automatically. We want to do it in automation. And we want to add those automated tests. So we want to verify that, for example, looking in the security context of our deployment. So I'm making sure that any deployment or stateful set doesn't deploy pods as root or as privilege. It does not change the privilege escalation, or doesn't have allow changes to the host file system, or a lot of process IDs or network IDs. So there are many elements that an early detection of this or an early scan of the security context of deployment can avoid some pitfalls, and we'll show you examples later on. We'll talk about pod deployments. Roles or permissions are another area which we think requires some attention. People may change or copy or take roles and just use them. And always there's a question is, do you really need to update the config map? Do you really need to put your verbs with a star, or the resources with the star, because you're not sure how to define, and how you can reach the least privilege method we all want to follow if you do it early enough in the CD. And we'll show some examples of things that you should be aware of. Last but not least, again, it could be a cliche as well, with secrets. So during the CI, I'm sure all of you scan the code, verify that it's not no one left SSH keys, or no one left some secrets or access key or secret key in the image, the hard coded itself. But sometimes there's also, or not sometimes people use it in environment variables. So Kubernetes has a great mechanism with secrets. I allow you to load the secret when the pod is deployed. There's no reason, or there's no need you need to expose your access keys or secret keys, as environment variables, deployment files. And again, this is something which we recommend to detect before you make the deployments. It's always better to find or detect the risks before they happen. And having said that, let's take maybe a deeper look and take, we can deep dive. So this is a classical deployment files. You can see the dependencies, not always getting the understanding of what exactly you're bringing in. I took in some examples for images, but of course you can see it happen a lot with roles and permissions. People just take a role, cut and paste, use it because it's easy, and just, it comes together with whatever tool they're trying to deploy. And it's not always the best or the most or the least privileged role that it's required. So just in a nutshell, how this role works in Kubernetes and why it's always better to detect it in advance. So Kubernetes has a very powerful mechanism of role-based access control. Okay, it allows to combine between what operations, which are called verbs, can be done on the API resources, and by who and by how. So it can be users, can be groups, can be service accounts, but we give permissions to subjects to do operations on API resources. So this is how it behaves. Now, when we deploy the things, obviously we have the subject, okay? We create a role, okay? A role can do something on some API resources, and then we make the binding in the deployment. Now, it's always good to verify, even before we make the binding, what are the roles are capable and what are we planning to bind them to. Why? Because obviously, when you do it in advance, you can making sure that you save mistakes afterwards. Now, if you can ask me what can go wrong, okay, what can work? So let's just take, an example of, how does the roles look like? You need to define certain sets, like for example, on your API groups, and they can look, for example, on the left-hand side. So I take the resources like services, endpoints, pods, and in the verbs, I allow you to create, update, patch, or delete. Now, if I'm going to make this binding to a user, right, then obviously I'll get super high permissions. I can do a lot of things on the endpoints, on the services, on the pods. I can pretty much do anything. Now, if this if this user or group or service account is compromised and someone can assume this role to itself and manage to it can pretty much do anything that he wants on the cluster, and game over pretty much, right? So it's always important to ask ourselves all the time. We need to review all the roles which we put in our pods for our deployments, stateful sets, review the verbs, the API, what resources are defined, and always better to eliminate those risks before they happen. You always try to make sure that we follow this least privilege concept, meaning we only grant the permission needed. It's not always the best option just to define things in a broad way to avoid mistakes. A lot of times, people are not sure when they make a deployment, what resource they're going to use, if things will change. So it's always kind of a common practice to leave it very wide, very open, because, it's always good to be prepared for whatever change. And our belief is that it's not. It's always be on the limited, on the least privilege, and then to update when it's needed. So that's definitely a concept recommended to follow. Cluster admin, too many usage, too many users, you get cluster admin. Not sure that's the right way. It's always better to limit usage because it can give you almost anything. And then verify that, create, update are really, you kind of know exactly who get those verbs and making sure what he can do about them. Now, I want to give you kind of an example of how it took in a real cluster. We took just a classical cluster or a classical deployment, where people define users, right? And let's take an example. Just take some regular example from here. We can see the different roles that this user gets. So in this case, he had 3 roles. At least 2 of them have some risk. You can see that, for example, here the user got on the config map to update config map. Not sure that's always the best way. You need to ask yourself always, is it really needed? Should I really grant it, or maybe should think twice? Just take another example from here. You can see here there's a lot of things. You can do a lot of things on events. For example, update events. So one of the classical patterns attackers will delete the events so they can hide any traces, or at least make it harder to detect. Creating endpoints, always a risk. Exposing secrets, deleting secrets, obviously. I think no need to add more to that. So as I said, these are just typical roles we found in a typical cluster, and a lot of times we see that people edit, not always taking into consideration the impact or the vast of what happened if an attacker can compromise the resource, and then you can assume those capabilities and do a big harm or a big damage or thing that unwanted in the cluster to the different containers. So this is something that if we do it right at the CD phase, we can of course prevent it from happening. Do need to reach, we can see, we can verify, we can scan, we can get this detection, and we can decide at that point if this is really needed or not before we make or approve this deployment. So this is why making this early detection can definitely help to your cluster or deployment security. So I hope everybody is well. So if you reached until now and you're not exhausted, so it's a good time to take a sip of your coffee, and we can start moving to the next topic. And the next topic is deployments, pod deployments. I call it the good, the complex, and the intuitive way. And the reason is that sometimes, the deployment of a pod, I see many Helm charts or many deployment files that just, leave the security context empty without even specifying or taking a closer look at what can be done or what should be done. And in order to get maybe a deeper view of why those security context is important, why it's important to harden the pod. Let's take a look at what happens, when an attacker attacks a cluster, or what happens when something wrong happens and there is a cyber event. So usually the first thing, of course, is, as Zohar explained before, is vulnerability. Vulnerabilities are great, especially if they happen on a common resource. Then the attacker will create an exploitation, and then this exploit will happen, and the attacker get control of the resource, whatever it is, right? Perfect, great. Now we are in. Now the question is, of course, is how we define our role, right? If we define it wide or narrow, because now what's going to happen next is after the attacker will find what it is, and usually in container, there are not too many things which can happen. Then my next case is, let's see what I can do, right? So now from, moving from the host itself, I'll try to see, where can I go? Whether it's the host, so I can get exposure to more containers, or whether I can move to other resources, right? Now, the best tools if there is, God forbid, an attack, and if there is a vulnerability which was exploited, to contain those exploits, is to verify that the pods are deployed securely. And security means that you contain the potential attack. You don't let an attacker to move away, to get into more resources. So I spoke before about the permissions, why it's always important to keep the permissions low. Let's see how we can isolate the container, how we can verify that the container is contained. And I think Kubernetes did a great job here with giving the native tools. And this is the pod security context. The pod security context allow any user to set up the needed configurations so they can really, really minimize, I would even dare to say limit completely, any potential attack or any potential, any potential escape from the containers. Now, pods are typically deployed with a predefined security context. And let's see what this context gives us. So if you look at the Kubernetes documentation, so you can see all the different attributes. Okay, we're not going to go all of them one by one, but I want to, to note few of them, right? Few of them which are important. So obviously, there are the classical tools like SLinox, Secomp, UpArmo. Those are the system calls that you can limit. You can limit your container from making. You can isolate it from trying to accessing those, which are known tools. And I think in Kubernetes there is a great effort, which is led by the security team, in bringing SecOps into Kubernetes 1.18. This is something which will allow users to define profiles, attach those profiles, and then of course isolate the container from trying to reach the host or trying to reach the operating system, which is absolutely a great achievement. I think it's going to be in alpha in the next release, and then so to be GA the one after. So this is no brainer. But let's look about something which is more close and concrete. Things like must run as non-root, right? Verifying that our container or our pod is not deployed as a root or does not deploy as a privilege. I think there's some other thing that we must pay attention to. And for example, this is something which I think a lot of people are overlooking it. The default value for allow privilege escalation is true. And from our perspective, this is something which always should be set to false, right? We don't want privilege escalation. We don't want container to assume more privileges or getting higher in the privilege chain than what you really set it up. So this is something that, if you're not going to take a look at it by default, it's going to be set as true, and which means that if someone is breaking in, it can, of course, alleviate its privileges and get, as a privilege and get more permissions and can really do a lot of damage. Other than running as a root, it's always good to limit the access to the host file system, leave it as a, read-only, doesn't need to be write. And of course, limit the volumes which you can mount and restrict. You don't need to mount all volumes. You can really define a limited set of volumes that you want to mount the containers, and there is great documentation on how you're going to do that. So Kubernetes also define not just the security context, but also define the pod security policies. And the Kubernetes Pod Security Policy is a cluster level resource that control the security context. So with pod security profiles, we can define the security context that we want to add to our containers. And as I said, that's a great tool. I encourage everyone to use it. A little bit complex to define it because we need to define the pod security policy. We need to create a role to do the role binding and allow and apply this policy on the service account that we want to apply it on. But it's slightly complex, but provide huge benefit to the users and can really minimize the attack surface or the potential attack that attackers can do if they manage to expose or to break into one of the containers. Moving next into our security stack, come the network policies. And I think network policies, there's a lot to talk about, doing different namespaces and isolating and creating this micro-segmentation. And I think there's a, it's not a new thing. But I think the more important thing is to see what I call the life outside the cluster. Because when we want to create on a day-to-day job, running in a cluster, there are many exceptions to the classical network policy rules. Like a popular one is when we need to create a network policy for resources which are not in the cluster. They can be, they can be like on-prem resources. They can be like cloud services, which are not containerized, like a database or storage, or just some on-prem resource that we want our pods to access. Now, obviously, the network policies are great when you were writing those policies internally, but in trying to get them or to cover things which are not containerized, things or elements which live outside the cluster, that's become really complex. And what I want to talk about is how we can make it simpler and how we can make it easy. Now, another example is multi-cluster communication. Sometimes, we have multiple clusters. We want to allow communication between them. We want to make sure that not just everything, but at least to expose those services that we want them to access, or at least verify that there is a minimal set of authorization, that not everything is exposed. And again, we do want to encourage and allow those communications. So those are kind of the typical use cases where the classical network policies require some boost in order to make it efficient and usable. So what I want to talk about is how to do it with service mesh. Service mesh has many benefits. Service mesh like Istio, for example, allows smooth definition. And if we want to example those two use cases, I think that this is where service mesh can really provide, among many other good values, great value to the users. So with service mesh, users can extend, the policies, the service mesh policies to non-Kubernetes elements. And this is something which will allow containerized application to communicate with elements which are not containerized. And this, as we discussed, this can happen, quite often. Now, service mesh create discover and routable path to those non-Kubernetes elements, so everyone from the cluster can read them, and we can set up a policy that who can do it based on the security consideration or what we want to expose and what we don't want to expose. And it also provides, consistent performance metrics. It can also provide a way to encrypt traffic. So if this traffic is going outside the cluster, we want to verify that it's encrypted because we want to maintain the zero trust model. Then with service mesh, this is done in a very easy way. So what we want to take from here is obviously that people will think about it. Deploying service mesh can really be a great way. And let's take a little bit, maybe a deeper look on how it's being done. So obviously, Istio 1.6, which was released not a long time ago, made a huge leap in making this connection much easier and simpler than it was before. In call it virtual machines in a single network mesh, and it's really done in a great way. Now, the challenge is that, in reality, there are some obstacles, there are some challenges, okay? You can see that there are few posts that you can see on how you can do it, what you need to do, why things not always work. And again, I think, in 1.6, there was really done in a very, very nice way. In portshift, we created some smoother way to do it. Okay, we kind of automated a few steps, which we recommend everyone else can do it. And those steps that we recommend, of course we use, is first create like a virtual pod, okay, within your existing namespace. So this is something that will help you to get a mutual TLS and MTLS certificate. And this MTLS certificate, of course, can be generated for this virtual pod, and then it will be later used for the VM, because if you're going to do it the other way around, until the VM will get a certificate, until it will be replaced, known, it will take a long process and long time. Then the next thing that we recommend to do is create an installer that copy this certificate and additional settings into the VM. Okay, so now the VM will immediately can start communicating with your cluster. The installer should install the issue expansion and the envoy on the VM, okay, with the copy attribute that you created for this virtual pod. And then the next thing of the script is to sync the services, okay, sync all the services and verify that everything in the cluster and the VM are aware of each other. And once they are in sync, you know, we can ensure very smooth flow of communication. We can ensure policies can be created, services can communicate, and we can get full control of any pod that we want can communicate, traffic can be encrypted, and we're getting a smooth process to connect elements which are not containerized with containers, with pods, and do it securely and smoothly. So this goes about net service mesh or network policies. And having said that, Zor, I hand it over to you to talk about cluster security. How do you verify your cluster is secure?
Hey, thank you. And let me share my screen back. Yes. So a very important element in Kubernetes is Kubernetes API server. So this server serves as a, when you do a kubectl or you use HTTPS API for Kubernetes, you're actually accessing this server. So it's and whenever a pod gets up or something is happening, this Kubernetes API server is accessed, and we'll see in a moment what security measurements are standing between an attacker and the resources. The more basic one is the role-based access control that Ariel presented a few slides ago. So there we can determine who can do what, where, and in which action. So either a human user or a pod can access this Kubernetes API server, and after being authenticated and authorized by the role-based access control, given the right permission, it also there is also admission controls that can be applied and can look at whether this is a valid action or something suspicious, and only then the relevant action is actually taking place. So looking at the role-based access controls is very tedious. So you have long and huge YAML files displaying role-based access controls. It's very hard sometimes to sort them out and read them all. And the ideal protection scheme is if we can, at runtime, audit all the APIs invoked toward the API server and actually let the user know, this API server has a risk, and if the risk is maybe high, maybe medium, or it's a low risk. But let the user decide whether they want to actually mitigate this risk or allow it. In runtime, we can also block commands that create a high risk or violates security best practices, so some kind of a compliance policies that the enterprise has. And we can also detect abnormal scenarios. So in order to break out from slides, we'll do a short demo. So you can see here, a typical, this is a typical thing that I would want to do. I would like to prevent workloads from modifying at runtime. So the basic attack is actually to do a kubectl and connect to these pods using SSH. So you can see here I have an SSH access to the client, which is not best practice, but it's possible. So let's leave out this window, and we can look at how this looks at our monitoring events. But before, let's just change the rule that prevent modification in runtime. Now it is in alert mode, and we'll just change it to block mode. So we'll change the policy. And we apply the policy. So we look at the events of the last 5 minutes. So we can see here that I was alerted on something that happened. So someone connected using SSH. So actually it's me. So I can identify this someone, and I actually did an SSH towards some resource. It was the client. So now, after we change the policy to block, so let's try to do the same. So now you can see that it says that an admission controller is actually the admission controller on the slide that was the optional stage after the role-based access controls. So an admission controller actually blocked my operation, and I was not able to access using SSH the pod. So you can see here that this was blocked. So what can we learn from it? So role-based access control are very important, but not always they are. It's easy to manage all of this, and it's better to have another layer that will protect you and actually govern according to policy what's allowed and what's not allowed in the API server, which is the basic step towards an attack. Accessing using SSH a pod, copying files to it, and then hell breaks open. So thank you for that, and let's go for Ariel for final comments. So let's go back to the slides. Ariel, the share is yours.
Thank you, Zohar. I'll share my slides. You know, Zohar, maybe perhaps we can use your slides. Okay, let me share mine. Wait a second. Okay, cool. All right. Okay, perfect. So, summarizing everything, I think one of the key topics that we want to discuss, or at least we hope the message was passing, that accurately assessing the runtime environment is critical for the security health. And assessing the runtime environment doesn't just mean, image scanning, or does just mean, that I just verified that no one is managing my account, but it goes much deeper than that. It goes into your CI/CD processes. It goes into your permissions, into how you set up the pod security policy or the pod security profiles, and how you're making sure your security is hardened. It even goes beyond scope of what we discussed, like deploying in different namespaces, creating segmentation, using network policies for the segmentation. There's a lot of things that can be done. Kubernetes defined many native tools which should be done, and again, they should be done. They should be done carefully. We talked about the role-based access control. Great tool, must be used, but always need to make sure that we're doing it wisely, and we're leaving it, as in the least privilege approach. Talking about API or cluster management. So Zohar just showed how that, not just the worker nodes should be taken care of, but also the cluster, the APIs, who's doing what they're trying to do, eliminating or preventing malicious attempts or malicious attacks. These are all must be taken into consideration. More specifically, or maybe use cases, it's always sometimes we need to kind of have a broader view and sometimes look beyond just the cluster, look a bit what comes outside the cluster, how we create it securely. And again, just like Kubernetes, there are many open source tools, Istio, for example, that can do a great job in, I would say, increasing the level of the security, increasing the usability of our clusters. So all in all, I hope you enjoyed today's webinar. We tried to give you coverage of all the open source tools, everything which can be done in order to get an holistic security and increase the security hygiene of your clusters. There are some things which we want you to, or you can feel free to use. There is some links which make some, which are available, whether it's for the Kubei, the open source. I also shared it in the chat for those who are interested in. There are a few blogs which we wrote and are available on our website where we describe those capabilities and what the best methods or some tricks and tips that make your life much easier in deploying them in pod security policies, what's called PSP, or how you create a secure multi-cluster policies and secure authorization delegation to making sure that you can make multi-cluster in a secure way, or just talking about the motivation for the runtime scanning. So thank you everyone for coming to our webinar tonight. Thank you, Zohar, for this great presentation. We hope you enjoyed it. And we're now going to be ready for Q&A.
Yes, so I see, Ariel, a few questions from the crowd. And the first question was about Kubei, whether it's a CNCF project.
Okay, so I think I answered in the chat while you were talking, and I said it's not a CNCF project. It's an open source tool that we wrote in portshift. You can see in the top link, it's available in GitHub. You're more than welcome to use it. We encourage everyone to use it. Give us feedback, provide PR. We want the community to use it and make it nicer. And of course, we can talk about the roadmap and what's coming on next on Kubei.
Yes, and the next question was, are there plans to have a Helm chart available for Kubei?
Thank you, Zohar. So again, of course, and that's what we are kind of hinting, there is a roadmap for Kubei. Kubei is not going to stay as is. We're of course working on making it nicer and better, and we encourage the community to contribute as well. Helm charts is the next plan. We're working on adding this part to Kubei, so not just to scan images, but also scan Helm charts and alert users on the different threats, whether it's coming from a security context, from roles, or just from secrets which left exposed. And of course, there's an even longer term roadmap. We want to add some more engines and do some calibration so we can get better accuracy of the different CVEs and getting kind of at least multiple sources and multiple events. Things like executable scans. So not just images and packages, but also different executables to verify that there's nothing hiding between those dependencies.
Okay, thank you, Ariel. It was an exciting webinar. We sure hope to see you all in a future CNCF webinar. So thank you all, and goodbye for now.
Thank you, Zohar. Thank you, everyone. Christy, I think the ball is yours.
Thanks again for a great presentation. As Zohar and Ariel mentioned, the recording and slides will be available later today on the CNCF webinars page. Have a great rest of the day, everyone, and stay safe. Thanks.